Hello and welcome to this course. Today we will delve into an important programming language of the World Wide Web space, and that is JavaScript. I think this course will be fairly large, and I think I'll make it a two-part course because there are a lot of things to discuss about the JavaScript language and still a lot of things to discuss about the document object model. So today's course is about the JavaScript and the document object model of the browser and how these two match. Okay, so let's start. So JavaScript, it's a very important programming language. It's actually the most used programming language in 2019 and also 2018 to 2017, according to GitHub and Stack Overflow surveys, and always maintains top positions on other top charts. So it's a very important language. It's quite powerful, quite messy, and we'll try to cover a lot of things about the JavaScript language today. Although I must mention that this is still an introductory material, since JavaScript is very complex, very large, and we really do not have enough time to delve into all the details of the language. But we will briefly discuss most details of and most constructs of the JavaScript language. So JavaScript's main properties are that it is a lightweight scripting language. It is used in the browser. It's actually the only programming language that is natively supported by all the browsers. It is executed on the client side, that is within the browser. There is a JavaScript interpreter called the JavaScript engine that runs inside the browser. It's a good thing to mention that in recent years, well, not quite recent years, the JavaScript programming language also moved to the server side, meaning we have a server-side counterpart of JavaScript, and that's Node.js. If we have time, we will talk about Node.js in a future lecture. The language is fairly old. It was developed by Netscape and Sun Microsystems and first introduced into the Netscape Navigator 2.0. The Netscape Navigator, it's an ancestor of Firefox. Back in the old days, in 1994-95, there were two web browsers. When the World Wide Web was born around 1993, so there were two web browsers. The most, let's say, the most important one, which had the largest market share, like 95%, was in Microsoft Internet Explorer. But then Netscape Navigator came along, which was quite a nice browsers, and it evolved, and eventually it turned into Mozilla, and the source code was released, and then it evolved into the Firefox browser that we have today. The purpose of the JavaScript language is to add interactivity and dynamic functionality to HTML pages, meaning that it's just like, if you remember from previous courses, you know that in CSS we can actually change a little bit the view of an HTML document depending on user events, namely or mostly mouse over, so the hover selector. But then you've seen the extended style sheet language, XSLT, for XML, which was more powerful than CSS, because it could also change the structure of the document, meaning it could remove and add XML nodes from the current XML document. And along comes JavaScript, which is even more powerful because we can add interactivity to the HTML document, meaning we can do all the things that we can do in CSS or XSLT, but also get additional external resources, completely change the way the current HTML document looks like, completely change the contents of the current HTML document, react to events, not only to mouse overs, but to clicks and swipes and all sorts of gestures. Um, so this is the richness of the JavaScript language. It is interpreted, it is not compiled, making it a little bit slower than compiled languages. It is inserted directly in HTML pages. It is an object-oriented language that, but it's not the OOP concept that you know. You will see later on in this lecture. And it inherits many features from Java, but it is not Java. It is understood by most browsers, and it's an event-based language, meaning that most of the time the code, JavaScript code runs as a reaction to an event from the user, meaning a mouse click, page reload, a swipe, and so events like that. It is a weakly type language, meaning that a variable can change its type throughout the execution of the code. The JavaScript is an implementation of a programming language standard called ECMAScript, and the current standard version is ECMAScript 2019, that is ES10. But the browser performance is ECMAScript 2015 ES6 or 2016 ES7. So what can JavaScript do for an HTML page? Well, it can detect the type of the browser, whether it is Firefox, Chrome, or Safari. It can react to various events of the browser, and this is where JavaScript is mostly used. Events like clicks, swipes, and so on. It can alter the structure of an HTML document, meaning it can modify, delete, add new tags, move them around, remove them completely, and do this on the runtime. It can validate data before being sent to the server. For example, if the server expects an email address, you can validate whether the user inserted a valid email address before being sent to the server. Although an important thing to notice here, due to security reasons, it's always very, very important to duplicate this behavior at the server. So it's very important to do this data validation at the server also for security reasons. Because it is executed inside browsers, also due to security constraints, JavaScript cannot modify local files. So files local to the computer running the browser. The basic elements of JavaScript are simple data types that JavaScript inherits from Java. Operators and instructions. JavaScript has predefined objects, either objects from the language itself or DOM related. DOM is the document object model. It will be introduced later on today. It relates to the linkage between the JavaScript language executed in the browser and HTML documents. So these predefined objects are array, boolean, date, error, eval error, function, math, number, object, range error, reference error, regular expression, string, syntax error, type error, and URI error. You will see how we can use this this predefined objects later on. JavaScript has also some global functions: decode URI component, decode URI, encode URI component. These are useful for encoding URI or URLs, uniform resource locators, that are let's say the addresses of a resource on the World Wide Web. if they contain something else than just ASCII characters, then these functions transform the URI or URL so that they only contain ASCII characters. An URI is actually a superset of URL. So an URL is not this one. This is a local URL, uniform resource locator, so like the address of a resource. And this is a remote URL. Okay. And URI is a superset of URLs, but we will talk about this in a future course when we move to server-side programming. Okay, then that's this function eval, which is like an interpreter. It evaluates JavaScript code and it executes the JavaScript code. Then some functions for testing is finite is not a number, parsing float, so parsing a string into a float, parsing a string into an integer, and so on. Then the comments are written as usual, like we do it in Java or C++ or C#, so using / or slash and a star if we want to write a comment on several lines. JavaScript is, as I said before, weakly type, meaning that a variable can be bound to different types throughout the execution of the code. Okay, the types and literals, that is the constant values that we have available in Java, are numbers. We have integers in base 2, 8, 10, and 16, and real. But something important to notice is that although we have integer numbers, they are still represented as floats, real numbers. And you will see some issues related to this later on in this course. Then we have Boolean values, which are true and false. Then we have null and undefined. There is a difference between these two, but there is a subsequent slide about the difference between null and undefined. So I'll just tell you that later. The idea with undefined is that it's the value of a variable that doesn't yet have an assigned value. Not a number. Then a string. JavaScript supports Unicode characters. We can write strings using single quotes, double quotes, inverse apostrophes. Actually, this notation with inverse apostrophes, which is also called template literals, it's much more powerful than the previous ones. In JavaScript, most of the things are objects, including string. So you can apply string class methods on any string, including a literal, including a constant. So you can write something like this, which returns the length of the string, which is 3. Using inverse apostrophes, we can write strings that span over multiple lines. Then another literal, another constant is vector or array. We can write it like this. Actually, arrays and objects are just dictionaries or maps. So this one has 5 elements, but the second one and the third one are empty, are null, although it has 5 elements. We can place pretty much everything in a vector, from simple types like numbers, like this one, strings, but also objects. And objects, which is, as you will see later, are just dictionaries or just maps, which are just an array of one or more properties or methods. So you see here this object dog, which has one property named dog with the one property with the name and the value dog, another property with the name type and the value animal, and another property with a method called characteristics, which is equal to this method. I think this is a mistake. I don't need to actually call the function, but just specify the name of the function. another property h4, or yeah, we can view this as a property, not as a method, in which case that is correct, because this function is called here and the result of this function is attributed to this property. But more on objects and classes later on today. So those were the constants, the literal types, and now the distinctions between null and undefined. So null, it's just like in Java or C++, it's a value representing the absence of a value, and undefined is a value of a variable that hasn't got a value yet. So in order to see the difference, you can see here, so this we can declare variables using var. This one is equal to null, it's initialized to null, and this one is not initialized, meaning the value of y is undefined. Okay. Moving on to variables, so we've talked about literals, constants, and now we move to variables. As I've already said a couple of times, Java is a loosely typed language, also a dynamic. It's also called a dynamic language or weakly typed language. It means the same thing. It means that a variable can change its type throughout the execution, and the value of a variable is automatically converted to other types when necessary, depending on the context. Is the so-called implicit type coercion mechanism. And the type of variable does not need to be declared. It's just like in Python or PHP, which are also weakly typed programming languages. A variable can be declared using the keyword var or let, or just by assigning a value to it without any var or let, like this. This one, this is declared using var. This is declared without anything. This is declared using let, and this is declared without any var or let. Here we have the plus means string concatenation, and this one, the root variable is a string. This one is a number, an integer, but it's automatically converted to a string and concatenated to this one so that I gets this value. We have two types of actually we have three types of scope, three types of scope in JavaScript. We have the global scope, where a variable is accessible throughout all the code. We have function scope, where a variable is accessible in the function where it is defined, and block scope, where the variable is accessible only in that block, like a for loop block or while block and so on. Let variables, so variables defined using let, have block scope. This let keyword was introduced in ECMAScript 6. And var or no var variables, meaning variables declared with var or declared without any keyword var or let, they have the global scope if they are declared outside of a function, or they have the function scope if they are declared inside a function. So we have these three types of scope where the variable is visible, that is the global scope throughout all the JavaScript file. The function scope, so inside the function in which the variable is defined, and block scope, so the variable is visible only in that specific block. A variable, as I've already said, a variable without a value assigned to it will be evaluated to undefined or not a number, depending on the context. If it's a numerical context, it will be evaluated to not a number. If it's not a numerical context, it will be evaluated to undefined. And this happens, so a variable will be without a value will be evaluated to undefined or none if it was declared with var, or will give a runtime error if it was not declared with var or let. Okay, I've already told you this. Examples of function variables. Well, but we will talk more about the functional aspects of JavaScript. But for now, just notice that this is a function, and we can assign a function to a variable, to this variable f, and we can call this function like this, using the name of the variable and giving some parameters. but we'll talk a lot more about the functional aspects of JavaScript in subsequent slides today. Okay. We can define constants. Constants are just entities, just like variables that do not change. That do not change their values, and we are not allowed to change the value of a constant. And we can declare constant using const. The scope of the constant is always block level, so they have different value types, different literals. The one that I've mentioned before. This one throws an error because we are not allowed, we cannot change the value of a constant. Then moving on to the operators. So we've started with the literals, the entities, variables, and constants, and now we move to operators, and then we move to instructions of the JavaScript language. We have three types of expressions in JavaScript: arithmetic, which are evaluated to a number; string, which are evaluated to a string; and boolean, evaluated to true or false. These are the operators are pretty similar to the operators of a high-level programming language like Java or C++ or C#. So we have this assign operators, equal with addition, and equal with subtraction, and multiplications, and division, and the remainder, so modulo. Then we have bitwise operations plus assignments. This one's, I can't remember what this is, but this is shift to the left, shift to the right. This is AND bitwise. This is XOR bitwise, and this is OR bitwise. Then we have comparison operators, equal, different, larger, larger, equal, smaller, smaller, equal. Arithmetic operators, which are the usual ones: modulo, division, incrementation, decrementation, addition, subtraction, and power. So raising a number to an exponent. Bitwise operators and or XOR, not, bit shift to the right, bit shift to the left, and I don't remember what this was. Logic operators, so AND, OR, and NOT. The string operator, which is so plus for concatenation, and we have all sorts of special operators which are described on the next slide. We have identity operators. You'll see some examples of this. So because we have the implicit type conversion mechanism that converts a number to another, for example, you will see that true, the boolean value true is automatically converted to the value 1 in numerical context, and the boolean value false is automatically converted to 0 in numerical context. So if we compare true with 1 using the two equal operator, so not this one, two equal operator, the result would be true, because true is equal to 1 if true is converted in numerical context. But if you compare it with this identity operator, which means equality and of the same type, then true is different than 1. Okay, so this means, so 2 equal signs is the equality operator, even if the parameters have different types, and 3 equal signs is the equality plus having the same type operator. And this is the negation of this one, meaning either the numbers, the parameters are not equal, or they are equal but they have different types. Then we have the ternary operator, which evaluates this condition and returns this result if the condition is true, or returns this one if the condition is false. We have this comma operator, which is a little bit different than what I know from other programming languages, in which all this expression 1, 2, and n are evaluated, and the result of this expression is the result of the last expression in the sequence. We have new for creating an object, similar to other object-oriented programming languages. We have the this operator, which refers to the calling object in a method, also like in other programming languages. We have type of, which returns the type of a variable or an entity or a constant. This one is string. We have delete for deleting an object, but also we can delete just a property of an object or an element from a vector or a method from an object. You will see later on. We have the in operator, which checks whether this property name or this property number belongs to this object. We have instance of, which checks whether this object name is an instance of this class. And we have void, which evaluates an expression without returning a value. I've already told you about automatic type conversion system, which is also called implicit type conversion. I think all dynamic weakly type programming languages have an automatic type conversion system, including Python, PHP, also JavaScript. And when applying operators, JavaScript automatically what does this mean? When applying operators, JavaScript automatically can convert parameters to the same type in order to apply that operator, depending on the context. So you see here, this 2 is converted to string and concatenated to string. Okay, here. Then this one, this 2 is automatically converted to a string and concatenated to 3. This true is automatically converted to the integer value 1 and added to 2, so the result is 3. Here we have false converted to a string and concatenated to string. This one evaluates to true because this empty array is automatically converted to 0 in a numerical context. Here this one is converted from string to a number, to an integer number, and subtracted from 10, so the result is 9. And we are starting to see one of the problems of the language. You see here 2. So we have here an integer and a string, and the integer was converted to a string. And here we have also an integer and a string, and the string was converted to an integer. So it's the reverse of this one, and that is a problem of the language. And we will see at the end of the course some quirks of the language. There are a lot of them, but you will see that later on. So this is the automatic type conversion system of JavaScript. Moving on to instructions. So far we've talked about the literals that are the constants, constant values that we can use in the JavaScript language. Then we've talked about variables declared with let or var or without any keyword. Then we've talked about declaring constants. Then we've talked about the operators that we can apply on JavaScript objects. And now we will talk about instructions. The instructions are the ones we have in Java. So we have conditional instruction, that is if or switch. As I've already told you, we can have different values in the condition of if or switch, not necessarily Boolean values, because everything is converted to Boolean in that context. So we have the falsy values, the usual false, but also undefined is converted to false, null is converted to false, 0 to false, not a number to false, empty string to false. Then we have all sorts of cycle instructions, so loops for do while. We have label which is used in order to break from a cycle with break label or continue label. We have different types of for. Actually, there are 2 types of for here, where this one, so in this one, the variable cycles through the properties of an object, so the fields of this object, and it executes this statement. And here, variable cycles over the property names of this object. So here the variable cycles over property values of this object, and here variable cycles over property names of this object. And we also have with, which applies this object to all the statements here. If we don't want to to write the name of the object and then dot the method name. We can write with object and just call the method, and the object will be, or the object would automatically prefix the method. And then we also have exception handling instructions, try and catch and throw, similar to Java. Okay. Some examples of using for cycles to parse an array. As you will, so this is an array. This is an array. This A is an array. But as you will see later on, arrays and pretty much everything in JavaScript are objects, so we can also assign a new property or add. So we can add a new property to A here. The test property is added to A. So we add a new test property with the value foo, and we can, but this is added to the object array A, and we can parse the value, the components or the values of A, like using a regular for, like this. So for I equals 0, I is smaller than the length of A, which is here 3. Then print the value of A index I, which will print X, Y, and 23. Without this one, this is a special added property. We can use the for cycle like this, where the variable I takes the value of the property names of A, which are the indexes, okay? Because arrays and objects, as you will see later on, are just dictionaries or maps. They have key value pairs, and the key, the implicit key in an array, is just the index. So that's why it will print 0, the index of X, 1, the index of Y, 2, the index of 23, and test, which is the index of this foo property, okay? This test is the key, and this one is the value. Remember that this for var I in A parses, so I takes the value, takes as value the property names of A, and then we have this one, which takes as value the actual the value of the, so in this example, I loops through the values of the properties of A. That's why it will print here the values of the properties, which are X here, Y, and also 23, without printing this one, because this is a special added property, this test. I forgot to mention you that the console log just prints something on the console, which is the web console. Let me show you. Let me open something that we'll probably use. This test. It's not important. But this is the console. You can access it by pressing F in Chrome. You can access it by pressing F12, or just right click on the page and then click inspect, and that's it. You see here the elements of the HTML elements of the current document, and this is the console. And if you write in JavaScript something like console, this is actually a JavaScript interpreter. Here you can write console log, I don't know, test or hello. Yeah, and it will print hello. You can also write a complete JavaScript program here. So let's say let A equals 2, and then let's say let B equals A plus 1, okay, which is evaluated to undefined. But if I write something like this, B, that will give me the value of 3, okay, or A will give me the value of 2, which is the value of A. Yeah, we can declare a vector here if we want to. So A, B, C is this vector, 1, x to y. So we have different data types in the vector, and we can parse it like this. For var I in C, console log C, sorry, console log I. Okay, and we see here the the indexes of this of these elements. So 0 is index of 1, 1 is index of x, and so on. Okay. So here we see that form of for with the property names or the indexes, and if we use this for this of, then the I will take the value will take as value the values of the properties. Okay, something like this. So 1x to y. We can also attach a property like we did before. So c test equals foo. Okay, in which case this one will not print foo, as you've seen on the slides. This one will also not print the index of foo, which is test. This one will print the index of foo, which is test. And then, but if we want to actually print the value, we can do something like this. So c index I. And in this case, it'll print 1, x, 2, y, and foo. Okay, remember that c was this one. Okay, 1, x, 2, y, and test with the value foo. Okay, as you will see in later on when we talk about PHP, and I think you already know it by now. So this C is any array, any vector is just a dictionary, and this one, so it's formed of key value pairs. This one actually has the key 0, which is its index. This x has the key 1, which is its index. This 2 has the index 2, which is its index. This y has the index 3, which is its index, and this one has the index test, which is a string. Indexes can be either integer or string. Okay, so this is the web console. Let me leave it this way, maybe we need it. Okay, zoom to full screen. And there's also a fourth for loop introduced by ES6, ECMAScript 6, which is like this. For each element of A, we apply this function, which is an anonymous function. You will see later on what anonymous functions are. So this is a function without a name, and this lm will iterate over the values of A, and will print lm, which is the value, which is one value of A. That's why it will print x and y and 23. Okay. Although we've attached here a property to test to the test vector, it is usually not a good idea to do this because you see it's a bit harder to print the value of this one. It doesn't print this full value unless we write here a index I. So it's usually not a good idea to add properties to a vector like this. Okay. So these are 4 cycles, and you've seen in the previous slides the instructions of the JavaScript programming language. Okay. Now let's talk a little bit about strings. Strings are objects. They have native Unicode support, so each string is formed by Unicode characters, and each character is 1 or 2 UTF-16 code units. Each code unit has 16 bits. As I said, strings are objects, so we can call methods on them. This here it's a a list of methods of the string class. It's not all the methods of the string class, but the most important ones. We can apply these methods on a string variable, but also on a string constant. And this one, char at, returns the character the character at an index. From an index, this one concatenates this string to the current object, but we can also do that with a plus. This one checks whether this string is included in the current string. So remember, all these methods are applied on a string object, which is the current string, this string. And returns true or false. If true if it finds the string, false if it doesn't find the string. These methods are similar to the previous one, so it checks whether the current string starts with str or ends with str. It returns the index of this character in the current string. This one checks whether the current string matches this regular expression where we have special symbols, as we do in a regular expression. This one replaces, in the current string, replaces this substring with this one. This one searches a string into the current string. These two methods are very powerful. This one extracts a substring from this index to this index from the current string, and this one splits the string, and so it tokenizes or splits the strings into parts and returns an array of strings of substrings which are separated by the separator in the current string. So this is useful if you for example have a statement, so a sequence of words, and you want to separate that statement into words. You just use split and use a separator space. Or if you have a multi-line string and you want to get all the lines from the string, then you need to split using the separated \n, which is the new line. You could do that too. Okay. Collections are arrays. We can create. You've already seen how we iterate over arrays using the for loops. This ones. So we can create an array like this, like you've seen before, so like that. But we can also create it like this using the array object. This one creates an array with 3 values, 2, 3, and 5. This one creates an array with also 3 values, this time string. This one creates or instantiates an array with a specific length. And this one does the same as the previous one. Remember that an array, or know that an array length is actually the highest index plus 1. So it's not a good idea to use. So it's not a good idea to do something like this. So it's not the number of elements. For example, here we have the A array, which has 3 values. They have the index. This one is 0. This one is has the index 1. This one has the index 2. But then we can add another value with the index 20 in the vector. So now A has 1, 2, 3, and 4 elements. And then if you want to print the length of A, this would be 21. So let's continue. Let's also list some of the important methods of collections, so available for the array objects. We have concat, which is useful for joining 2 arrays into one single array, into one new array. Then we have the join, which joins all the elements of an array into a string using a delimiter like this one. The default one is comma. Then we have push for adding 1 or more elements to the end of the array. Then we have pop for removing the last element from an array. Then we have shift that shifts the elements of the array by removing the first one and returning the first one. Then we have another important method, which is slice, which extracts a portion of the array from the start index to the up to index. Some other methods are splice, which removes some elements starting from this index. It removes count to remove elements, and optionally, it can add some other elements instead of those removed. This ones. Then we have reverse, which parses in reverse order the elements of an array, so that the first element becomes the last, the second one the last but one, and so on. It returns a reference to the array. Then we have sort for sorting the elements of an array. Then we have index of for searching an element into an array. Here, starting from an index or starting from index 0. Then we have the for each for parsing an array. You've already seen an example with this. It applies this callback function on each element of the array, and then we have the usual map function, which is similar to this one. It applies this callback function on each element of the array. So it maps this function on each element of the array and returns a new array, which is computed by applying that callback function on each element of the current array. Another important function, global function in JavaScript, is eval, which is useful for evaluating an expression, arithmetic, boolean, or string, but it's also useful for executing JavaScript code. So if this string is an expression, it evaluates the expression and returns the result of the expression, and if the string is a sequence of JavaScript statements, it executes those statements. We see here some example. So here it adds 2 plus 3. The result of eval is 5. Here the result of eval is 6. We can use variables inside the string used for evaluation, like this one. Or we can write complete JavaScript code like this one, in which case it will create a global variable 2 and will print the value of x, which is 2, on the console. So it will execute this code. Now, moving on to functions, JavaScript is not a pure functional programming language like, for example, Lisp, but it has many functional aspects in the language. So JavaScript is a functional programming language because functions in JavaScript are first-class citizens, meaning they can be saved into variables. You've already seen an example before, but you will see more throughout the following slides. They can be passed as parameters to other functions, as callback functions. They can have properties like other objects, so actually a function is an object, and they can be defined without an identifier, meaning we can have anonymous functions. So let's see. So functions are usually declared in the head tag of the HTML document and called all over the HTML file. The syntax for declaring a function is this one. So function, then the name of the function here, and parameters and arguments and the statements that form the body of the function. The reasons we have these two types of arguments are the fact that these parameters are the actual parameters of the function, but the function can also have a variable number of parameters which are stored in arguments. So arguments stores all the parameters of the function, and we can access them using arguments index I, where I goes from 0 to arguments length, and the parameters are the explicit parameters of the function. Okay, it is something like this. Let me try to show you this in a web console. So here I have this function f1, and I have two arguments, x and y. Okay, and it just returns return x x plus y. Okay, so this is a function with two parameters. If I call it f1, 2, 3, the result would be 5. But I can also call the function like this, 2, 3, 4, and the result is still 5 because this 4 parameter is ignored, okay? But we can still access this parameter in the arguments array inside the function. Okay, so if these are explicit parameters, these are explicit parameters x and y, but we can give several other parameters to the function, which are accessible through the arguments concept. Okay, so the rest of the parameters are accessible using the arguments concept. All primitive parameters are passed through value. So only object properties can change. Only object properties that are changed inside a function are visible outside. But most of the entities in JavaScript are objects, so you can change. You can change objects in a function, and the change will be visible outside the function. If there is no return in the function, JavaScript returns undefined. You have already seen that in the web console. Okay, we can also so in the using the keyword arguments inside the function, we can access all the parameters, including those explicit parameters x and y in our previous example, and the rest of the parameters. But let me just take you through this. Using the rest construct like this one, so writing 3 dots here and rest args, this rest args get only the arguments that follow the first 2 arguments in this example. So not like arguments construct before, which takes which includes all the parameters of the function. This one includes only the rest of the arguments besides the first 2 ones. Okay. For example, I have this call of function f, and in this case x will be equal to 1. So the formal parameter x would be equal to the actual parameter 1. Formal parameter y would be equal to 2, and rest args would be a vector which will be equal to 3, 4, 5, 6. Okay, and we can parse it using this form of for loop. But we can use all forms of for cycle out of those 4 forms. Okay, we can have functional expressions or function expressions. Function names can be used as arguments for other functions or values for variables. For example, I have here a function cubic, which returns the cubic of a number. Then we have here a square function, which returns the square of the number. This function is assigned to this variable, okay? And we have some other function here that has 2 parameters. A is an array, a vector, and f is a function. And it actually applies and prints on the console. So prints on the console the result of applying function f to each element of the array, okay? And then we can call this map function using the cubic function and the vector v. So this cubic is this one, or we can call it using this variable, which is which has the square function as its value, okay? And of course this one will print 1, 8, 27, this one will print 1, 4, and 9. Okay, moving on, we can create functions also using the function constructor. Function is an object, this one, and we can create it like this by specifying the parameters x and y and the body of the function, which is return x plus y, and we can call it like this, okay? Remember that we can assign functions as the value of a variable, in this case the sum variable, and we can call the function by using the name of the variable. functions created with the function constructor do not create closures of their creation context. You will see in a couple of slides what a closure means. It basically means an inner function, so a function that is declared inside another function, a nested function. They are created in the global context. They will only be able to access their own local variables and global ones, so not the ones from the scope in which the function constructor was called, which is not the case for closures. Closures can access variables from the scope in which they are defined. And all functions are actually objects, as I've told you, of prototype function. We can also add properties to functions if we want to. So most of things in JavaScript are objects, including functions. We can also have anonymous functions like this one. So this one does not have a name. This is useful when we have when we want a function that is only called once. We can assign it to this variable and call it here. Or we can have an anonymous function like this and automatically called like this. Okay, so here we have a function definition, but it is also automatically, this function is also automatically called with the argument 3 when it is defined. Okay, so it returns 9. The function scope. Variables defined inside the function cannot be accessed outside the function. But a function can access all variables from the scope in which it is defined. If the function is defined in the global scope, well, it can access all the variables defined in the global scope. The global scope is formed by symbols and functions defined on the top level of the JavaScript file. If the function is defined in other function, it is called a closure. It can access all variables and parameters defined by its parent function and all variables to which its parent function has access. This is what it means, a closure. And functions are hoisted, meaning that you can call a function first and then declare it later. It works this way. Okay, closures are just inner functions, and as I said before, an inner function can use the parameters and variables of the outer function, while the outer function cannot use the arguments and variables of the inner function. So this is a form of encapsulation, encapsulating the variables of the inner function, similar to object-oriented programming encapsulation concept. An inner function can only be accessed from statements inside the outer function, so the parent function, but not outside the parent. Example of a closure is this one. This inner is a closure. It is called here the parent using the parameters a and b. The parent function is the outer function, and all these variables, the parameter of the parent function a, b, and this variable of the parent function can all be accessed here in the inner function. And in addition, also the closure, the inner function, can access all the variables and functions that are accessible to the parent function. If this outer function is defined in the top level of a JavaScript file, it can also, this inner function can also access global variables and global functions defined on the same level as this outer function, because the outer function has access to global symbols in this JavaScript file, as long as the outer function is defined in the top level, on the top level of the current JavaScript file. So this closure can access the parameters and the variables accessible to its parent function, to the outer function, namely a, b, and c. This is the concept of a closure. Also a nice feature of JavaScript is the fact that we can have default values for parameters, which is not true for Java, for the Java programming language. So here I have two arguments, two parameters, but one of them has a default value. We can call it with only one parameter and the other one will be 0, or we can call it with two parameters if we want to, and in this case b will have the second value. Okay, this one, for example, returns 2. because A would be 2 and B has the default value of 0. ECMAScript 6, so ECMAScript 2015 ES6 introduced the fat arrow notation, which has shorter syntax. In order to write a function with parameters param1, 2, and n, and then a bunch of statements, we can write something like this. So the parameter names in round brackets, and this arrow, and the statements that form the body of the function. If the body of the function is just an expression that is returned, then we can also skip the curly braces. This one, okay? So this is actually equivalent to this arrow and return expression. The parentheses are optional when there's only one parameter here. Sorry, when there's only one parameter in the parameter list, then the parentheses are optional, so we can write this or without the round bracket, like this one. And if the parameter list is has 0 length, so if there's no parameter, we still need to write a pair of brackets of parentheses like this. You will see an example on the next slide. So here I have this array of strings, okay, and then here I print something on the screen by applying the map. So I'm applying the map function. I'm calling the map function, which is a function, which is a method of the array class, and as parameter of this map function. Remember that the map function, which was described in a previous slide, the map function has as parameter a callback function, and it applies that callback function to each element of the materials array. And in our case, the map function is this one, which has m as parameter, so an element as parameter, and it returns the length. M is a string because each element of materials is a string, and this one takes the element, which is here denoted by m, and returns the length of the string, which is the length of hydrogen is 8, the length of helium is 6, the length of lithium is 7, and the length of beryllium is 9. Okay? So instead of writing a callback function like function m return m length, we just use this arrow notation. So it's a much shorter syntax, but you will see more examples with the fat arrow notation, at least when we talk about promises later on, asynchronous programming, still today. Now we move to another important part of the language, which is object-oriented programming. So we talk about objects and classes in JavaScript. JavaScript, it's a prototype-based language that does not distinguish between a class and a class instance. So it doesn't actually have classes, although there is a keyword class that can be used in order to create a class, but that's just syntactic sugar. It doesn't actually have classes like other object-oriented programming languages, for example, Java or C#. So it only has objects, no classes, and you create objects by first describing a blueprint, a prototype of an object, and then cloning that object to get additional objects. An object is actually just an associative array, so a dictionary or a map, augmented with a prototype. Almost all objects in JavaScript are instances of object. And JavaScript objects inherit properties and methods from the object prototype. Prototype is just a property of the type object. So throughout JavaScript, the prototype pattern is used to create new objects, meaning that you first create a blueprint of an object and then you clone it to create another object. The current object is, as in other programming languages, is referred with this. Inside the function, this refers to the object on which the function is called. if that object does not exist, meaning the function is called without a this qualifier, this is the global object, the browser window. Very different than other object-oriented programming languages. This can mean different things inside a method. So, well, actually it refers to the object on which that method is called, but it's not always so predictable what this object is. For example, if we call a method that's an event handler, then this object will not be the object to which the method belongs to, but actually will be the object corresponding to the tag on which that event happened. But you will see this when we talk about events. So it's not as straightforward as in other programming languages. So predicting the value of this for a current method, for method execution, is not as straightforward as it is in other object-oriented programming languages. To summarize, we actually have two syntaxes. So everything, so JavaScript does not distinguish between classes and objects. We only have objects, and these objects are just prototypes or blueprints, and they are cloned in order to create new objects. But we have two syntaxes used for creating objects in JavaScript. The first one is the classical one, the functional one, where we declare an object, properties and methods using a sort of a constructor-like function. And then there's the new syntax introduced by ES6, where we actually have keywords, class and extends and static. And it looks very similar to the way we work with objects in Java and C++, C Sharp, and so on. But it's just syntactic sugar. Behind the scenes, we still have only prototypes, only objects in JavaScript, which are cloned and modified by adding or removing properties and methods. So we start with the first syntax, the classical, the functional one, and then we'll move to the new ES6 syntax. So in the classical syntax, we can create an object in three ways. The first way is using an object initializer, where we specify the object name and then property 1 equal to value 1, property 2 equal to value 2, property n equal to value n. We can also have method equal to a function. Let me see if I can zoom this out so that you can see better. Yeah, so you see it here. Okay, yeah. And then we can the second alternative to build an object is using a constructor function or an object prototype, where we have this print function. We need this in the object, and the constructor function is this. We create the object thing. We create it here, new thing, giving us parameter a, b, and c, and the constructor function is this one, which just sets the properties of this object, which is this object created here. So sets the value of property 1 of prop1 to x, where x is a parameter, the value of prop2 to y, the value of prop3 to z, and let me also zoom out. And sets this method called method1 to this function print, which is described here before. Okay, and then we create the object like this. So we have a constructor-like function like this one, and the name of the object is given by the name of the constructor function. And the constructor function just sets values for actually declares properties and methods of the object. These properties and methods should be prefixed with this prefix, and we create a new object like this. Okay. Or a third way of creating objects in the traditional syntax, traditional way, is to create an object which, if you remember, is the ancestor of most objects in JavaScript, and then add new properties to it. like this. So the person is the object, and we add a new property just like we do with an array by specifying the name of a property and the value of the property. And here we added another property. We can also delete properties from an object using delete. We can delete the whole object using delete object name, but we can also delete properties by writing delete object and dot property, or we can access a property using the dot notation, the classical dot notation, or the way we access a property in an array using an index, or using just the name of the property as the index. In an array like specification. And we can delete this property by placing a delete in front of it. So delete object dot property would just delete the property of this object. New properties, as you've already seen here, can be added to an object on runtime like this. It's this example here. Okay. Let me show you a sort of a complete example. So an object creation using the prototype example. So we'll actually use this constructor-like function here. So we have here a function which just prints something. This is a student, and this first name and last name. And we have this constructor function which constructs the object student. It has 3 parameters. It sets the value of first name and last name and year, and it has also a method, say hi, which is equal to this function. Say hi, okay. Please notice that all the properties and methods inside the constructor function, the properties and methods of the object inside the constructor function are prefixed with the this operator. And we create an object of type student here. We initialize this with these 3 values, and then we can call a method on this object like that. So this is object creation. This is object creation using the traditional or the classical functional notation. Okay. Moving on to ECMAScript 6. ECMAScript 6 introduced, so ECMAScript 6, which is ES6, which is ECMAScript 2015, introduced syntactic sugar in order to declare objects in JavaScript the way we do it in many other high-level object-oriented programming languages like Java, C#, and C++. So using keywords class and inherit and constructor and so on. Although the internal model remained the same prototypical, so we still have prototypes, no classes, but objects that are blueprints or prototypes which are cloned in order to create new objects. Okay, so the class is just a syntactic. The class keyword and extend and so on are just syntactic sugar introduced by ES6. But it makes the JavaScript code look a lot more like classical OOP code written in Java or C++ or C#. Okay, here we declare the same class student. We have a constructor which initializes the properties and also declares the properties of the student class, and we create the student object the same way as we do it for with the classical functional syntax like this. Okay, but this time code looks much more similar to classical OOP code in Java. Okay. But we can also have class expressions just like we have function expressions in JavaScript. So we can declare an anonymous class here, and the object declared by this class will be attributed to the stud variable, or we can have the stud variable be equal to a name class which has only one parameter, this one. So Here we have two variables. This one receives an unnamed class, which is declared in the variable definition statement, and this one has a named class, which is declared here. Okay, so these are class expressions. Let me show you a larger example, which includes method declaration, static method declaration, setters and getters. I'm not sure whether you see this very well, but I think I have this example in an HTML file. So let me see if I think it's this one. Yes, so it's this one. Let me zoom in. Okay. So I have here the class student, which starts here and ends here. It has this constructor. It has three fields: first name, last name, and an array of grades. Besides this two properties, first name, last name, and besides these three properties, first name, last name, and grades, we can also add pseudo properties or aliases using getters and setters. So we can never specify getters and setters for the properties we already declared here in the constructor, but we can add additional ones using get. So we add a study year. This is the getter of the study year, and this is the setter of the study year. We just return this study year, and sorry, we yeah, this is a mistake. Should have been study study year. Okay. And there's also a mistake. This one returns the specialization, and this one sets the specialization. Okay. This one, so the setter is used here, but I'll tell you about that later on. Here we have a method addGrade, which adds this grade to this course. So we just this course is a string, and we just specify this grade is it's a dictionary, and we specify that the grade for this course will be this one. Okay, so grades is a dictionary, this is a string, and this is a number. And then we also have a static method, which is declared using the static keyword, say hi, which just prints something. In this method, we are not allowed to use the this prefix. And this method can only be called on using the student class name, not on any instance of student. Let me see how. Let's see how we. Sorry. Let's see how we declare an object of type student. Okay, so this is an object of type student with this first name and last name here. Here the constructor is called this constructor. Okay. Then here we set the first name to Forest, the last name to nothing. And then we also set the study year to 2 by calling this setter. This setter is automatically called here. The setter for specialization is automatically called here. So this setter is called here. I think I'm not calling the getters. I would call the getters if I would print this, but I'm not printing it. Then I'm calling the method addGrade, which adds the grade 8 to the web programming course. And then I'm printing first name and last name and grades of the student, and then I'm calling the method hi. Remember that I've told you this method, because it's static, I cannot call it using the variable or the object start, but I need to call it using the class name. Okay. Let me zoom out. I think this is, or maybe leave it like this. And this file is loaded here, I think. Let me clear this out. I think it's due to this error. Let me see what's the error. So line 15. Oh no, so I need to, yeah. I need to leave this the way they were. Okay, here I have the name. The result of this print, which is the first name and last name, but last name is empty. So it just prints forest and the grades, which are web and grade 8. This is an array, remember? And then calling the method hi here. And this f1, which is the code I've added. I'm not sure whether this is the right, yeah, this is the right file. Okay, let me reload this. Let me see the source of this. And let me find f1. I don't know where this function is and why is it called. Let me close this and open it again, but I don't think this is the solution. Okay, so that example was this one. Let me see the web console. Okay, yeah. So I think so although we've cleared the console and I've declared function f1 previously, I think it should have been destroyed after refreshing this, but I think it didn't refresh the page. So now, yeah, now it just prints forest and this is a student. So it's this example. Let me go back to the presentation. So it's that example that you see it here. And moving on. As I've already told you, inside the class methods, you should always refer to the members of the class, either properties or methods, using the this prefix. So here, here, and here. So you need to use the this prefix in order to refer to members of the class, either properties or method. We also have public and private fields, but they may be not they may not be supported by all the browsers, in which case you need a transpiler like Babel. More on Babel later on, but namely Babel is just a transpiler is a compiler which takes a source code and translates it into another source code. So more specifically, Babel takes the source code of JavaScript code written into ES, a larger, a greater version of, a greater level of ES, and converts it into a source code described into a lower version of ES. So we declare global fields like this, and private fields like we declare public fields like this and private fields like this, and we need to keep referring to private fields like this using this sharp notation. Okay, we can also do class inheritance. Let me zoom in. Like this. So we have this person with a constructor like this, and this function say text, which just prints something. And then we have the student, which extends person. It has a constructor like this one's. We need to call in the constructor of the derived class. We need to call the constructor of the base class by using this supper. Okay, it also adds a new field here, grades, and it overrides the method say hi by first calling the method from the base class and then printing something in addition to the console. Let me zoom out. Okay, this is class inheritance. Some predefined objects of the JavaScript language. We have array, as you've already seen, but we also have map and set for working with maps and sets. We have boolean, you've already seen, function already seen, which specifies a string of code to be precompiled as a function. We have date, math for date for time and date values, math for mathematical functions, number for numerical constants and represent regular expression string. You've already seen symbol, which is new to ES6. It's used to identify objects. I haven't used this one much. And JSON for JavaScript object notation, which we will use a lot when moving to server-side web programming. Some other features of the language are template literals, which is just syntactic sugar, but it allows the definition of more powerful strings. It allows us to embed expressions into string constants. Template strings are written between inverse apostrophes, like this ones. So this is just a string, or sorry, this is just a regular string, but this is a template literal where we can use the variable inside the string. So this name will be replaced by forest inside the string. We can declare a multi-line string like this. And we can also use expressions, arithmetic expression. This would be replaced with the value of this expression, which is 6, automatically inside the string. Template literals is a nice feature of ES6. Another nice feature of ES6 is the spread operator, this 3 dots, which is used for cloning or copying an array or an object. So, for example, if we have this array, if we have this A array here, yeah, then we can create a new array B, which includes the value of all the values of A and additional values. So now B has the value 1, 2, 3, which were the values from A, and 4, 5, 6. Okay, so it creates a new array with the values of A plus additional values. We can just copy the array A into C. We can also copy objects. If we declare an object with property prop1 and prop2, we can copy it into an object copy like this. But we need to use curly braces for objects. And we can also arify the letters of a string. This is a string, and if we write it like this, the string, then it creates an array with the letters of the string. So it arifies the string hello. We can also call a function with an array parameter. So normally if I have this function declared with the fat arrow notation, this function has 2 arguments, 2 parameters, arg1 and arg2. We should normally call function f, then parentheses, then the value of the first argument, the value of the second argument. But we can also do this using the spread operator. So if we have a vector, we can call the function with this vector. And the value of the first argument would be 1, and the value of the second argument would be 2. Another nice feature of the JavaScript language introduced by ES6 is deconstructing. If we have a vector like this one, this A vector, then we can deconstruct it and select specific components, specific values of the vector like this. So this one would assign to first the value of the first component of the vector. The second value would not be assigned to anything, and the third value would be assigned to third. So first would be 1 and third would be 3. Then we can do this with objects. So here we have a student object which has 3 properties: first name, last name, and age. We can deconstruct a student object by assigning variable name the value of the first name of this object, which is Forest, and we assign to the variable age_val the value of the age field in the student object. So name will be Forest and age_val will be 41. We can still do it. So here I've changed the name of the variable. So I've changed the name of the variable that will be assigned that will assign, so I've changed the name of the variable that will get the value of a specific property from the object. In this case, name gets the value of the first name property of the object, and age_val gets the value of the age property of the object. If I don't want to change the name of the variable, I can do it like this, in which case last name variable will get the value of the last name field of the student object, and the age variable, the new age variable, will get the value of the age property of the student object. Okay, so last name will be equal to Forest and age will be equal to 41. Now we should also talk about strict mode. So strict mode, it's something very useful because in order to correct errors and to optimize JavaScript. As you've already seen, and you will also see, JavaScript is quite flexible in declarations. This can also cause problems because you get, for example, in a function you have a parameter and you don't know the type of that parameter. Okay, you will create a function that receives, let's say, a number as the parameter, but you don't know who calls this function, and you don't know the calling. You don't know what type of parameter the calling code will put there as the first argument. So you can use the strict mode in order to, but JavaScript tries to, if it finds an error, if the error is not critical, it may print something on the console or not print anything, and it tries to overpass that error. This may be problematic because later on that small problem can turn into a larger problem. So you may want to handle errors as they appear. And this is what the strict mode does. The default way of running JavaScript, the default way of running of the JavaScript engine is the so-called sloppy mode, in which non-critical errors are passed over and optimization is harder to achieve. And we can move to strict mode, which introduces some restrictions to the JavaScript engine. It eliminates some JavaScript silent errors by throwing errors. It fixes some mistakes that make the code harder to optimize, so it creates more optimized or better optimized code. And it also prohibits the usage of some symbols that are marked as keywords in future versions of ECMAScript, so that this code will run without changing it on future versions of ECMAScript. We apply the strict mode by writing ustrict in the beginning of the script. Actually, strict mode can be applied on the whole script or on a function level, to the whole function, but not to a block. And we invoke the strict mode by specifying ustrict in the beginning of the script or the function. Please note that it's tricky to concatenate two JavaScript codes, one that uses non-strict mode and the other one that uses strict mode. Because if you have one that uses the strict mode and you concatenate that with another script that doesn't use strict mode, then the whole thing would be in strict mode. So this could create problems. Some examples of mistakes that are converted to errors by JavaScript strict mode. So we use strict. This one, if you have a variable that's not declared with var, this one so if we have no global variable mistype variable that is declared with var, then this line throws an error. This is very useful because we may have a variable declaring the global context using var, and then we may write that variable name wrong by skipping a letter, for example. But JavaScript doesn't complain because we don't actually need to declare variables. We can just specify the name of the variable and initialize it with a value. But this is not what we meant, okay? We wanted to use that global variable, okay? And this is why this strict mode is useful, because it throws an error here, signalizing that we didn't declare this variable, okay? And it's very useful because it allows us to correct errors as they appear, and it doesn't let the error build up and become something more complex and something harder to fix. Also, errors are thrown if I'm trying to modify non-writable values like undefined and infinity, which is allowed by non-strict mode. And also it throws an error if I'm trying to redefine a property like this one, okay? The reserved words which are reserved in strict mode are implements, interface, let, package, private, protected, public, static, and yield, which are used. For example, let is used, static is used. The other ones are not yet used. They will be used in future ECMAScript versions. Let's also talk about modules. Back in the old days of JavaScript, the JavaScript code that run inside the browser was a very simple code, similar to what you have in the lab tasks. So you just need to do simple things, handle events, and so on. But recently, the JavaScript code that is executed inside the JavaScript engine increased. So now we have complete frameworks that run inside the browser, like Angular, React, and so on. So the code gets much larger, the JavaScript code gets much larger, and if it is larger, it makes sense to divide that code into modules. Module files are just regular JavaScript files, then they can have the extension JS, the regular JS extension, or MJS from module. It's a good idea to serve modules from an HTTP server, not from the local file system, so that you don't run into cross-origin resource sharing issues. We will talk more about this when we get to server side. A module can export any kind of symbol, var, let, const, function, or classes. They all need to be declared in the global context, so they need to be first level symbols. And another JavaScript code can import every exported symbol from a module or just some of them. Modules are imported, this is very important, modules are imported into the scope of a single JavaScript script. They are not available in the global scope. So let's say we have this module.js. This is how we export symbols. We have this module.js with the following content. We have this constant, which is exported inline here. We have this variable, which is exported inline here. And we have this function, which is exported inline here. Instead of writing this exports for each symbol we can also write one single export statement at the end of the module, which exports everything. Okay? In order to use those symbols and to import them in some other module, we do it like this. So here we had module.js file, and here we have, let me do this again, sorry. Here we have main.js. And in the main.js module, we import the symbols from module.js like this. Import symbol 1, symbol 2, do something from module.js, or import everything from module.js. Okay, And this main.js is used in an HTML file, and in that HTML file we have to include it using the regular script, source main.js script, but we need to further add this type attribute which specifies that this is a module, or this script has modules. Okay, so we need this to specify, we need to specify this in the HTML file in order to work. If we have several modules, it makes sense to create a module object for each module. So we import everything as module 1 from this file, from this module, and we import everything as module 2 from this file. And if we want to call functions from module 1, then we call them using this module 1 prefix, which was declared here. And if we want to call functions from module 2, we use this module 2 prefix. This is useful in order to avoid namespace issues and name clashes. Then we can also a new feature of the language is dynamic module loading. So we can load a module dynamically, and after loading it, we can do something. If this is not null, we can call functions. This is the promise syntax asynchronous programming, but we'll talk more about this in a couple of slides. Okay,